Okay, now we start talking about a new topic, which is a very, very important topic, and I can say that's the most important one in statistics 1. It's called the standard normal distribution. This whole chapter is normal probability distribution, and the first topic we're going to talk is the standard normal distribution. When we talk about a standard normal distribution, I believe that we have mentioned about the normal distribution earlier in early chapters. And when we talk about normal, it's like a bell-shaped to look like this, right? Right. There's a line here. So this is called a bell-shaped. And the reason that you see this bell-shaped, which means when x go from left to right, this is the number line, and then this curve is the probability distribution graph, and you can see here is pretty high and here is low, right? So that means when the number x is somewhere around this, then the probability is pretty high. And then for when x gets greater or smaller, when it's more and more greater and less and less, then the chance gets a little bit lower. You do see this type of distribution a lot because the data kind of like focused or concentrated in the middle. A lot of data focused in the middle, and then to the larger or smaller side, then we have less and less data. So that is the bell-shaped, right? So this is the first requirement or the first feature of the standard normal distribution, that is a bell-shaped. I think this is quite easy to understand. Now we know normal means bell-shaped, and what about the standard? The standard means mean is 0 and standard deviation is 1. So you can see that's a very standardized, right? Because the average is 0, which means here is a 0. So here is positive and here a negative numbers. And the sigma is 1, which is the standard deviation is 1, or the standard normal distribution. The standard normal distribution has a standard deviation equals to 1. So that's the 3 features for standard normal distribution. Okay, if you have a graphical calculator, you can do this. You can just plug in. I don't know if you're good at the calculator, if you can put in e to the negative 1/2 x minus mu over sigma square divided by sigma root 2 pi. Okay, so let's see if you put mu is 0 and you put sigma equals 1. Then you're going to simplify this as y equals, so here will be e to negative 1/2 and x minus 0, which is x, over 1, which is x again, so that's 1/2 x squared. And here is sigma is 1, so that's only square root of 2 pi. And then because this is negative, you can flip it down to the denominator, and this is a 1/2, so that's going to be the square root. So therefore you're going to have this square root of, you have this 2 pi, and then you have this e, and this negative is gone because you flip that down there, and this 1/2 is out, so you have x squared. So if you can put this in your calculator, then you're going to see a graph look like this. There's a bell-shaped, and when x here equals 0, and maybe around here is 1. So you're going to see that kind of a distribution. The graphical calculator can show you this. However, we don't ask you to remember this, and I'm not asking you to know how to do it. It's just something a little extra. If you like, you can just go ahead and try to plug that. And one more thing you might have noticed, that it's symmetric. You see that? So you can put that as a number 4 or you can add that into number one, say bell-shaped and symmetric. It doesn't really matter. So those are the requirements or the features of a standard and normal distribution. Okay, so after this very, very brief introduction, let's talk about something else. Okay, it's called a uniform distribution. Uniform distribution. Again, this time we talk about a continuous variable. So x is continuous, okay? So it's not a discrete. The probabilities that we learned in early chapter, for example, binomial and Poisson, those are the discrete probability distribution. Then starting from now, we're going to talk about a continuous variable only. Okay, so I will give you one example, so you're going to see what does that mean. Okay, what does a continuous variable and what does the uniform distribution mean? So let me look at this example. All right, now during certain time periods at the JFK airport in New York City, passengers arriving at the security checkpoint have waiting times that are uniformly distributed between 0 minutes and 5 minutes. So if you want to graph that, it's going to be this. This is the waiting time or waiting time in minutes. Okay, so that's between 0 and 5. So here's 1, 2, 3, 4, 5. And this is the probability. All right. Now, if the waiting time is uniformly distributed between 0 and 5, so it's going to be look like this. Okay, so that's a graph of this probability distribution. Do you know how high this should be, or what is the y coordinate of this line, or y equals to what number? Okay, you're going to connect that, become a rectangular. And remember the area under the curve, area under curve or function graph is probability. This is the most important thing that you're going to remember. So if the whole area under this line is 1, and here the length is, see, from 0 to 5, that is 5. So that will be, the height will be 1 divided by 5, right? Which is 0.2. So here should be 0.2. All right, now, once you have this, without this vertical line, you don't really need to have this vertical line. Okay, so once you know this, this is your graph of this uniform distribution. This uniform distribution is dealing with the continuous variable x, which is from 0 to 5, and the line or the curve is a flat. And that is called a uniform, right? Uniform means the same. So that's a flat curve. All right, now let me ask you the question. And what is the waiting time? What is the waiting time? Let's see, I will give you one. Find the probability that a randomly selected passenger has a waiting time of at least 2 minutes. At least 2 minutes means from 2 minutes to 5, right? More than 2 or more. At least 2 or more. So that means from 2 to 5. What is the probability that, you're going to write this, x is greater than 2? All right. Now, what we're looking for basically is we're looking for the area under the curve when x is greater than or equal to 2. Of course, x will stop at 5. So you're going to draw the line here, and then you're going to shade this area. And this area is your probability. So that would be length times width, right? So that's 0.2 times 5 minus 2, which is 3. So that's 0.2 times 3. The chance is 0.6. Okay, so the waiting time of the passengers is uniformly distributed between 0 and 5 minutes, then what is the probability, or the probability of a passenger's waiting time is longer than or at least 2 minutes is 60%. So 60% of the chance that they're going to wait for at least 2 minutes. That makes sense, isn't it? It sounds good, huh? Okay, so the other thing that if you remember when we did the discrete probability distribution, and then we can find what is the probability that x equals 2. So what does that mean? This means what is the probability that a passenger's waiting time is exactly 2 minutes. Basically, you're looking for is the area for this line. So that would be 0. You are not going to be able to find the probability of exact x value. See the difference? That's the difference between the discrete probability distribution and continuous probability distribution. For continuous probability distribution, you have a range like 2 to 5 or 2 to 3 or 1 to 4, things like that, and then you find the probability. So it's very obvious. You just look at the curve and find the area under the curve. Okay, so waiting times can be, basically waiting times is a continuous variable from 1 to 5. It can be anything, any number. It can be 1.23456 minute. Okay, it's just super accurate. But what is the probability that this passenger's waiting time is exactly that number? The chance is 0. All right, so that's the general idea about uniform distribution. It's really nothing hard for uniform distribution, but I want to use this to emphasize this concept, the area under the curve, that is the probability. Okay, now let's look at this. Let's look at the standard and normal probability distribution, which is like this. It's bell-shaped, right? Because every time when I draw that, it's bell-shaped. And then the mean is 0. So here is 0. It's right in the middle. And the standard deviation is 1, so somewhere here. And then 2, and then 3. And here is a -1. Oops, sorry, it's not very in the middle. And then -2 and -3, things like this. So that's our bell-shaped distribution. And the whole area under the curve is 1. Very good. So the probability of x, actually we use z. For standard and normal distribution, the variable we always use z, or we call that z-score. Okay, every time you hear z or z-score. So the probability that x is greater than -infinity to +infinity, the chance is 1. Now you see this? The probability that the z-score is between any negative and a positive, basically any real number. So z can be anything here. And then we talk about the area under this curve, the whole curve. So that is what? Now let me ask you this one. What is the probability that z is greater than 0, less than +infinity? Greater than 0, less than +infinity. This is a number line, okay? Remember, this is the number line. And we have the z is from here all the way to the right. So that's from 0 to +infinity. And the area under the curve is going to be this, isn't it? Yeah? Okay, so what is this area? It's going to be just the 0.5, isn't it? So that's 0.5. It's 1/2. And the very similar, we have a z greater than -infinity and less than 0. So that's from -infinity all the way to 0, and we talk about this area under the curve, and that is also 0.5. Now let me ask you a quick question. Okay, I think you should know this. What is the probability that z is less than +infinity and greater than or equal to 2? That means from here and including this line, right? Because this is called inclusive, right? Less than, greater than, equal to. This is less than, so 0 less than 0, z greater than 0, so it's only to the right. But here it could be starting from this point to the right. It doesn't make sense when you do like in algebra 1, algebra 2, even pre-calc, that you're going to draw a circle or a solid point, right? Depending on whether you have an equal sign or not. But in this case, because we talk about the area under the curve, we don't care about these lines area. So this is also 0.5. Isn't it interesting? So you notice that when you work on the probability distribution for continuous variable, you don't really care about this equal. Okay, of course you cannot be, for positive and negative infinity, you don't have equal, but for any other value, you put equal or not, doesn't make any difference. Okay. Now, I will give you another graph, because we're going to draw this a lot. Okay, we're going to draw this curve a lot. Here's a 0, and here's 1, 2, 3, just approximate, because you don't really need, you're not that accurate. And this is a z. Every time when you have this, a standard and normal distribution, you're going to put a z here. Okay, definitely do that all the time. All right, now we just learned earlier that the probability is starting from 0 and all the way to right, and that is a 0.5, right? So from here to here is a 0.5. What about this one? How can you find that? Do you know that? You don't. Okay, now if you go to our e-text, you know how to go to our e-text, right? You go to Canvas or somewhere, or you can use this table A2 at the end, and or there are a lot of standard and normal distribution tables. You can find it anywhere. There are a lot of them online. You can download it. Okay, so I got this. This is in our textbook, and this is I found that online. Now I want you to look at this. This one said the standard and normal distribution table values represent area to the left of the z-score. And here all the z's are negative, and here all the z's are positive. And keep in mind, we're talking about to the left of the z-score. All right. Now the other table, the other type of table they give you, they said a negative z-score. See, here is a negative z-score, so they give you the area to the left of it. And then for positive z-score, and then they give you the area to the left of it, which is this shaded green area. All right. Now the way you use the table is, if I give you 1, if I give you z-score is 1, I'm looking for the area to the right of 1. There are two ways to do it. One is you find what is the area to the left of 1. Okay, so which is this white area. And then you subtract this from 1. Basically, you're looking for the probability that z is greater than 1. That will be the probability, it's going to be 1 minus the probability that z is less than 1. Make sense? Because the greater than 1 is this shaded area, and the less than 1 is this white area. That add up to 1. So if I can find the probability that z is less than 1, z is on this number line, okay, and the probability is the area. Now we are going to be able to use this table. See, we have a positive z-score, and then the way to find it is here, the first column and the top row is the z-score. Did you hear? Let me make it really big. Oops, let me make it really, really big. Okay. Did you see here? Let me focus that. Okay. Did you see here? Here the z starting from 0.0, and then here is 0. So 0.00. This is in the 100th place. So 0.00. Did you see 0.5? Of course, there are 3 zeros after that. So we're talking about to the left, the area under the curve to the left of 0, that is 0.5, isn't it? That totally agreed with what we just learned. Now for 1, when z equals 1, then you should go down here. Did you see here? 1.0. And 1 is 1.00. So here's 0, 0. Do you see? 1.00. So what we have is a 0.8413. Okay, so that means this should be 1 minus 0.8413, and that answer will be 0.1587. Done. That's your answer. Okay, so what is the probability that z is greater than 1? Z is greater than 1. It's 0.1587. So which is this area? So that's your answer, 1587. When you give me the answer, you should give me 4 digits. Okay, you should give me like a 4 decimal places for the probability. The other way to do that, the probability, okay, I'm gonna make it bigger. So the probability that z is greater than 1 is the same as z is less than -1. What does that mean? That means this area should be the same. I just draw that here quick. So here's a 1, and here is -1 to the left of a -1. Because this graph, this bell-shaped curve, is a symmetric, so therefore this and this greater than 1, here less than 1, should be the same. So we can find by looking at the negative z-score table. And then we should look at it for z equals -1. And you're going to find here -1. Okay. You see here? -1.0. And here's a 0, 1.00. Did you see 0.1587? Here. Make it really big so you can see. Okay. Okay, better. Sorry. Here. Okay. -1.00. Did you see this? 0.1587. Okay, that is our answer. We just get the answer right away. So that is 0.1587. So this two method, this is the first way to do it. This is the second way to do it. Either way, you should get exactly the same answer. All right. So now I know how to find the area from a number to the right or to the left. Okay. The other one is you can print out this table because this table has a larger font. I like this table a lot because this is also to the left, which shows the same thing as the other one. And we just look at it to the left of 1.00. Did you see that? They get a 0.15866 because that have 5 decimal places to the right. So either way, you can just round it up to the 4 places. So you should have 0.1587, and then that happened to be the same answer. Okay, so this one I just downloaded from internet. It's very, very easy to use. It's the same thing, and this font is much easier to read. All right. Okay, so we know how to find the area. If I give you a number, try to find the area to the left or to the right. What about this one? What about? Okay, I like to do here. Okay, what about if I ask you to find the probability that the z is from negative, sorry, it should be straight, okay, 1.5 to 2.5. I'm looking for this, which is what is the probability that the z-score is between negative 1.5 to positive 2.5. How would you do that? And our table, all the table we have, it only give you from certain point to the left. So we can find when z equals 2.5, if you look at the table, the area you'll find is from here, and all the way to the left, okay? And then if you subtract this little white area from the one you found earlier, you're going to find the difference, which is the shaded area. So that will be the probability that the z less than 2.5 minus the probability that z less than negative 1.5. Okay, so you just need to look at the table twice. Find this number, and subtract. You don't really need to write this for me, but you should be very clear in your mind what you're doing. All right, so from negative 1.5 to 2.5, it's going to be, we check the area to the left. We use a positive z-score, and then we check a 2.5. Now I ask you to do 2.5, which is 2.50. So 2.5 is 0.9938. See that? 0.9938. So this is 0.9938 minus. The next one is the area to the left of a negative 1.5. So we look at this to the left of a negative z-score. And then we should look at it for negative 1.5, and you get a 0.0668. Okay, so that's this area. It's 0.0668. Again, be very careful when we talk about the probability or we talk about the area under the curve. It's always positive. Okay, at least it's a 0. So you should never ever give me a negative probability. Make sense? You understand that? Okay, 668. So I use my little calculator. It's 0.927. And there should be a 0 here. It doesn't matter you write it or not. So this shaded area is 0.9270. And then you're going to put this in the box to show me your answer. All right, now I give you 2 examples. The first one, I ask you what is the probability to the left or to the right of one value, or what is the probability between 2 values, the z-score between 2 values. So you're going to use the table twice. Going to check the table twice. All right. The some graphical calculator like TI-83, TI-84, they both can do that. And online there are plenty of the tables that you can do. All right. Now let me give you a couple of more things, a little bit more exercise. Okay, 0, and that's a z. So when you see this, that's a standard normal distribution. Okay, I will ask you what is the probability that negative 1.645 less than z less than positive 1.645. This is interesting, isn't it? So here is a negative 1.645, and here is a positive 1.645. You see, you have to be very clear in your mind. You know z, and the z should be plot on this number line. Okay, so this is a z, and what we're looking for is the probability, which is this, isn't it? This is shaded area. Now, did you notice that you don't have 1.645 because this table only go to the second places, second decimal places. See here, 2.60, 2.61, 2.62. So here, this top row is only go to the second places. So what about 1.645? I want to tell you this. If you look at the bottom, it's a very interesting. Here, if the z-score is negative 1.645. This is a very special number, okay? So negative 1.645, the area is a 0.05. They give you that. You don't need to look at the table. Here's a 0.05. And of course, this is going to be 0.05. I said 5. Okay, sorry. So this is a 0.05, this is 0.05, add up to 0.10, right? 0.1. All right, now what is the shaded area? That is a 0.90. So 90% the probability, or 90% of the chance that your z-score is between positive and negative 1.645. Isn't it interesting? And I bet that you already saw what's under this. Here, hold it well. Focus. Did you see the other number? 2.575, 0.005. So what it says is this. What it says is, sorry, I just quick. So negative 2.575, and here's a positive 2.575, and they tell you this little area is 0.005, and here is a 0.005. Now what is this area? What is this white area? So here is a, I don't know why I keep writing 9. Okay, so 0.005 plus 0.005, I got a 0.01. And 0.01, subtract that from 1 because the whole area under the curve is 1. So here I got a 99, 0.99. That means 99% of the data, or 99% of the z-scores should be between positive and negative 2.575. Okay, I ask you to do one more. The last example, or the last exercise. Let's just use that as exercise. So here's a 0. 1.96 and a positive 1.96. Can you find me this probability in between? All right, now this is good because this is a z, and 1.96, at least we know how to do that. See, we're going to use this table. We find when z-score is 1.96, so we can find this blue area, and then we go to negative 1.96, we use another negative table, and then we get this tail area, and then we use this big blue minus the little blue. So let's look at a 1.96. So here is 1.9. Did you see that? 1.9. All right, so here's 0, 1, 2, 3, 4, 5, 6. Do you see this? 0.9750. So from here to the right, which is from here to the right, that is a 1 point, let's do that again, 1.96, 9750. 9750. All right, now what about this little tail? Okay, that's the negative, that's the negative z-score, and we also look at for 1.96. Okay, so let me just keep my finger here so I can show you clearly. It is 0.0250. So here is 0.0250. So what is the probability that negative 1.96 less than z less than positive 1.96, which is 0.9750 minus 0.0250? What do you have? You have a 0.95. Sounds very good. That means 95% of the z-scores are between positive and negative 1.96, roughly 2. If you remember, we learned in the empirical rule that about 95% of the data fall within 2 standard deviations of the mean. Do you remember that? 95% of the data fall between or within 2 standard deviation of the mean. Actually, to be accurate, is fall within 1.96 standard deviations of the mean. So all those three numbers, I hope you can remember them. 1.645 in the middle is 90%, and the 2.575 in the middle is 99%, and the 1.96, that's my favorite number, because then we're going to have 95% of the data within positive and the negative 1.96. Sounds good, huh? All right, now we can use the table backwards, but we will do that later. Now let's look at another example. I show you that, okay? The probability that a randomly selected person has a bone density test result below 1.27 is 0.8980. Another way to interpret this is 89.8% of the people have the bone density less than 1.27. I don't know if you have know this, because that was the bone density that some people, especially when they get older, then they check their bone density, and that's by z-score, okay? Below 1.27. Let's check. We're going to use the positive table. Okay, 1.27. Here is 1.2. You see, 1.2. I think I'm trying to make it a little better. Yeah. Let's not use this. The font is so small, and I like to use the bigger one. Okay, we're gonna use this one, and I hope that you can print this out and have this with you, because that will help you a lot. So 1.27, you see here 1.2, and then you go all the way to here 7. See, that's a 0.07. So 1.27 is this row and this column. You see that? Okay, where you cross each other, which is 0.89796. Of course, this is a 5 decimal places, so you round this 6 up. So here it's going to be 0.8980. Okay, so that is true. So here is a 0.8980. So that, again, this is the z-score and this is the probability. Okay, it's very, very interesting, isn't it? Now we're going to use the same bone density test to find the probability that a randomly selected person has a result above -1. So again, this is a z-score, right? So we're going to look at this. You're going to show me here's a 0 and here's a z. I always do this. I always do this when I do normal. So above a -1. So here's a -1, and we're looking for this. Okay. I think now you're the expert. Now you can either look at for negative z-score to find this little white area, subtract that from 1, or you find the area to the left of 1, and then to find that. So either way, the probability that a z is greater than -1, that could be when z is -1. See, -1.00, so it's going to be 0.1587. So that's going to be, this is 0.1587. Of course, if you like, you can always mark it there. So it's going to be 1 minus 0.1587, so it's going to be 0.8413. Okay, or the probability that z is greater than -1 is the same as the z is less than +1, because it's a symmetric. I just flip that along this axis, the middle line. So when x is less than here, to the left of the positive z-score, you see this? 0.8313, 8413. 0.8413. So either way, okay, either way, that would work. I don't really care which method you're using, as long as you show me the answer. So what is the probability that randomly selected of somebody, randomly selected person, his bone density result above -1, which is 0.8413 or 84.13% of the people. Okay, so that's quite a lot, right? Okay, and we can, I think we're okay with that. Now we're going to again we use this bone density again, and we use the correspondence between probability and the area. We conclude we gonna see what is the probability that a randomly selected person's bone density is between -1 and a -2.5. You know how to do that? So from -1, here's a 0, and you draw this. You're going to be very good at this. You're going to be better than me, okay? So here's 1, here's -1. And then we talk about between -1, -2, -3, and here's a -2.5. So I'm asking you, what is this area? Okay. Then you should look at for the area to the left of -1, subtract the area to the left of 2.5. So the probability that the z-score is between -2.5 and the -1, which is, we look at the negative, where is the negative? Here's this one, -2, we look at the -1 first, right? So we know that, we just found it earlier. So negative here, -1.00 is 1587, so that's 0.1587. Okay, we're going to minus this 2.5, so we look at the -2.5, which is 0.0062. 0.0062. So the answer is 0.1525. Okay, so that's this. Okay, so 15.25% of the people, their bone density is between -1 and a -2.5. Something not good. Okay, if you have your bone density score look like this, then you're going to be very careful. All right, and if of course if you have the bone density measurement or that score is less than -2.5, which means it's really, really bad. You got to see doctor. Okay. All right. Now we learned how to from the z-score to find the probability. Can we go from the probability go down to find the z-score? How do you find the z-score? Now I give you a little note. 0.25. Okay. What does this mean? What does this little number at the bottom mean? This is okay. This is called this is the z-score, and the probability that a z is greater than this z-score equals 0.025. So what does that mean is, that means I'm asking you to find z, and I give you this little area is 0.025, and I'm asking you for this z-score. Okay, so you see the idea, and what you should do is, sorry, here should be very vertical. All right, now when we have this z table, they keep saying to the left of it. So either you look at here, and then you look at the area part, the probability part to be 0.025, and then you're going to find this z-score, which is it's a negative number. And then when you write it down here, you just change it to be positive. Let's do that. So 0.025. Let's see where is 0.025. Here is a 0.000. We're looking for 0.02. So here's a 0.2. Okay, so we're somewhere here. So that's 27.025. 26. So you just keep going. Did you see we find this magic number 0.025. So what is that z-score? Negative 1.96. Negative 1.96. So here should be negative 1.96. Therefore here will be positive 1.96, which means the z 0.025 is 1.96. Okay, so that is, if I give you the area, then you use the table backwards to find the z-score. And we use z and we use the little alpha, so that area to the right of z alpha is alpha. Okay, so in our case, that alpha is 0.05, whatever value, right? 0.025, sorry. And then that is z with a little footage down there, and that shows the area to the right of it. And you just need to just use the table backwards to find the z-score. All right, now, okay. So let me ask you, we do the last one. All right, can you find z 0.05? Z 0.05. So it's going to be this area is 0.05. Okay. And we're looking for this number. We're looking for this z-score. If we're looking for 0.05, we can find this little tail area as 0.05 and find whatever z there, and then we just change the sign. So we're going to find where is 0.05. Again, we find 0, 0, 0, a lot of zeros, 0.05. Did you see here? Okay, so here is a 0.4 and a 0.5, so going to be somewhere. So 4, 3, 2.5, 5, it's in this guy. 0.05. That's what we try to find. Okay. However, we found that this is 0.0505. This one, this is a little greater than that. Little bit greater than 0.05. This one is a little bit smaller because this one is 0.49. If you round, it's going to be 4950. So can you tell that 0.0505 and 0.0495. 0.05 is right in the middle of this two, isn't it? It's right in the middle. So if that probability is right in the middle, then the z-score should be between negative 1.64 and 1.65. So what is the number between 1.64 and 1.65? What is the number right in the middle? That should be 1.645, isn't it? So this is 1.645. Okay. Sounds good. Okay, what about the z-score 0.95? Okay, that means we're looking for the z-score. Okay, to the right of it is 0.95. Remember, starting from 0 to the right is 0.5. Now you have 0.95, it's greater than 0.5. So therefore, you have to start from somewhere here to the right in order to get 0.95, isn't it? So this little area should be 0.05. And that is negative 1.645, just what we did earlier. So z 0.95 equals negative 1.645. There you go. Okay, so far we finished the first session, or finished the introduction part about the standard normal distribution. I think now you're ready to work on the homework.